So you will find that these two people's contribution. You may not be familiar with the third person. He is also Steve, and his name is Steve Wozniak. He was the associate with Bill Gates. I'm sorry, Steve Jobs. Actually, Steve Jobs and Wozniak were working together. Now, these are the people who were interested in music, who were interested in graphics, who were interested in menu-driven windows and the packages. So a lot of work which was original in nature in terms of developing these modern concepts of PCs, you can call it, was developed by Steve Wozniak. So both of them together worked actually. And in the early stages of Apple, the first version of Apple, as you know that Steve Jobs was then thrown out. Then he went back again and he first created a company outside. Then he went back to Apple and so on and so forth. But in the first phase of the Apple computer, the Mac machine that was developed, these two people worked together very closely. And the contributions that you see today, whether it is a workstation, whether it is a PC, whether it is nowadays, you will find that we can open up the windows and we can close the windows, we can start multiprocesses, and many aspects have been contributed. The original experiments were done by Steve Wozniak and Steve Jobs actually. So this is just a quick glance through the history, but the main important part is not to look at the history as history, but the main important part is to understand how computer science and milestones of computer science have been established over the last 100 years. And that is the reason why you will find that this course is a very tip of the iceberg, if I may say. And all of it, whether you are a civil engineer, whether you are a computer science, whether you are electrical, mechanical, all of you are involved in using these concepts. And therefore, I don't consider that one has to just know only because you are in computer science or only because you are in civil engineering. So just to summarize, I think we are dealing nowadays with two things. At a very fundamental level, we deal with atoms, that is the physics, and obviously anything physical that you have is at the heart, at the very foundation are the atoms. But there is also information riding on the atoms. And that information we are calling it as the bits. So you will find that if you look at the bits and atoms, the entire world around you is now full of bits and atoms actually. And therefore, today whatever the developments that are taking place, and every day, every quarter, every year, you see the field moves very fast. And the important part is the discrete nature of the bits. It's a digital world, it's a discrete world, and therefore the discrete nature of bits and also the discrete nature of packetizing of information, or the packetizing of the atoms. The atoms are essentially analog in nature actually. I mentioned this, I will not repeat it, about music, graphics, alphabets, numerals and symbols is the information that we are going to deal with. The concept of algorithm is very much at the foundation of all the work that we will do. But the one possibility is I write the algorithm and I ask somebody manually to execute it. It can be done. If you are a very disciplined person, you can execute that algorithm manually and write down the answer. Or I can then code and convert that algorithm in the form of a program, and the program is then executed through a machine. So obviously the machine execution of the algorithm is the program. And in order to run the program and in order to put the data has to be in a certain structural form. There are a variety of structures, mathematical structures that are used for inputting and structuring of the data, which are called as data structures. You know, whether it is trees, whether it is lists, whether it is arrays, you will find that you will be studying them. Now, the other subsequent development that has taken place is in terms of transmission of data over the wireless network, and that has become very important contribution in the last 20 years, and therefore you are able to now pass the information. The machine can be in Jamshedpur and the designer can be in Bangalore, and you can download the data onto the machine in Jamshedpur and cut the part there. So you will find that this is possible because of the wireless networks that we have. So machines can talk to machines, machines can talk to men, men can talk to men. So you will find that this is a very complex now network, peer-to-peer network of machines and men, possible because of the wireless communication. So you have got centralized computing, which was in the 50s and 60s, then it became distributed computing. Now you have got the mobile computing. Even if you have got a smartphone, you will find that you can do almost everything that you can do it on you have got the tablets, for instance. Tablets are nothing but the mobile computing platforms. So you have got now mobile computing, you have desktop computing, you have mainframe computing. A variety of things are now available to you. So now switching to the next part, which I would like to discuss, is that, as I said, that in order to deal with this man-machine interaction, the background, the mathematical or the logical background that you require has to be slightly different. When we give you a problem and when we want you to solve that problem, you will find that there are a variety of ways, and some of the ways that we use when we are going to use a computer are quite different as compared to the ways that you are familiar with. The discretization is also in some sense approximation for the kind of mathematics that you have used so far. So now there are these techniques. Obviously the names are very simple, but one has to understand, and each one of them is a very big area of mathematics, which is the foundation of computer science. Now if I give you an equation, let us say fx equal to 0. Okay, this equation could be let us say a simple equation like x square plus 5x plus 12 equal to 0, a quadratic equation, and I'm sure most of you know what would be the roots of this equation using the formula that you may have. But let's say I give you a very complicated equation like x to the power 5 plus 3x to the power 4 plus 12x to the power cube plus 25x plus 37 equal to 0. And I will say, tell me what are the roots of the equation, what are the values of x? Do you have a formula? Obviously not. But I need to know what are the equation roots, whether they are real, imaginary or whatever. So if I need to do this, and if you have just common sense with you, how will you do it? One possibility is that I plot this curve. This is a curve. So I can say that I plot the curve fx and x. Okay? And plotting it will tell me how many times and where it crosses x. Okay? Visually you can do it. But if I want to solve it through a logic, which I am going to require to develop into a computer program, there is a method called as divide and conquer. And what is that? You can see that this is the method which is on the left hand side. So basically what is the divide and conquer approach is, whatever is the domain that I have to search, what I try to do is to subdivide it and look at it in some fashion and then search over that area and then find out. If it is not possible, I want to do very simple things, but if it is complicated, divide it. Okay? If it is further complicated, divide it. Till you can solve, keep on subdividing it and take a summary decision about that subdivision. For instance, if you have got that curve which I have shown you, like whatever that fx curve is there, I can take 2 points, making sure that one is on the other side, one has got a positive fx, another one has got a negative fx. So I have got the range which is a to b, and that range is very large. I know that there is a fx equal to 0 point in between, because one is positive, the other one is negative. Now what I do is that I subdivide that b minus a range into 2 equal halves. Okay? So I set up a point in between and find out what is the value of fx. Evaluating fx is very simple for any x that I give. So x is equal to a, it is positive, x equal to b is negative, and a plus b by 2, which is the midpoint of these 2 points, I will find what is the fx. Now if fx is positive there at the point c, let us say, which is a plus b by 2, which means that a is positive and at c also it is positive. So definitely this whole range is not required for me to go further, because it is not going to cross the x-axis at that point. So I will discard the entire left half and then only look into c and b, because now I know that I am trapping that point, and I am trapping by reducing my search range every time by half. So what I will do, I will take C and B, again find out a midpoint which is D, and then find out what is the fx there. If fx is negative there, then the right hand portion I will discard, and that way I have, every time I am halving the interval and reducing it very close. Okay. And then I can have a tolerance saying that if x is within certain range, then I have reached up to the point. So this is a search technique of dividing and conquering. Now there are many mathematical operations, there are many operations. For instance, if you will find that there is something called as a binary search, and if I got alphabets, and if I want to find out a particular alphabet, and where is it, if I got the names of people, you know, so first I ordered them, and then I look at the search and find out that name very quickly through a binary search. Okay, so the idea here is, when it is difficult, subdivide it. And this is a very common sense approach, you know. When you have got 10 kids in the family and they are, you know, kind of quarreling or doing some problem, what do? You say 5 people go to that room, 5 people you go to that room, you know. And if 5 are still unmanageable, what do? Okay, 3 fellows go this way and 2 fellows go this way. When there is only one person to deal with, I am sure you know how to deal with that one person. Okay. So basically what we are saying is subdivide it. When you are in trouble, subdivide it. And that is what basically the philosophical or the common sense approach of divide and conquer. You will come across many problems in this course which will require this approach of divide and conquer. Okay? This is one way of dealing with or developing the strategies of problem solving.